All right, back at it now. So the problem we have, the next problem that I'm going to fix, rather, because there's multiples, is this little section here we talked about. We cleaned all the lights and checked all the lights the other day, and as we checked those circuits, it's now shown that the circuits for the lights are good. Was able to check continuity through all the lights, and that's how I made sure the bulbs were working, or would work, but they're not coming on. So then we go look, since these bulbs aren't coming on, then we go look at what drives those bulbs. Now, there's a couple of things to understand when you're looking at something like this. It's not just what's not working, but how is it that it's not working that helps clue you into where you should look next. In other words, if this bulb and this bulb was working, see they're the same color possibly, or if a couple of these bulbs aren't working right next to each other, then I would say, hey, there's a good possibility that this one circuit of the wires, and the way it works is that, see, red and yellow here, red and yellow here, red here, red here, black, black, you see. So what it does, it lights two at a time. It goes down this row, okay? But it's not just, if it was just one red wire not working, then I would go, okay, we need to look at that one connection. But it's not, it's the whole section. So what's common to the whole section? Well, the common to the whole section is the ground or the power, whichever way you want to look at it. It's probably AC current, so it really doesn't matter. But the main, so there's individual wires on one side of the circuit, and then on the other side of the circuit they're all connected together, and we proved that earlier by clipping onto one of the grounds and just chasing it all the way through. So since every light's not working, it's most likely the ground wire, the single wire, that does that. So then, but that may not be necessarily true, and we'll talk about how that works here. So what we have to do now is go back and figure out what is it that makes this happen. Remember, this is electromechanical, so there's no computer, and what we're talking about is this device right here. Now, in old pinball machines, they have what we call a score wheel, which looks like this. There's multiple, see the little notch right there, and there's a bump right here on this one, and a bump right here on this one. These are various cam wheels, and what these wheels do is that as the motor turns, these change, and these switches here operate up and down based on the cam. See the cam wheel here? So there's 1, 2, 3, 4 cam wheels that are in here. Looks like that middle one's not even being used. This one here is not even being used. That might be. Maybe it's on this. Oh, it is. It's used on this one down here. This down here does it. Okay. So each one of these cams activates at a particular time. And if you'll notice that the bumps or the holes in the cams, whether it's a bump out or a hole in, either way, they're all set. So it's a timing thing. So this one hits, this one hits, this one hits, this one hits, this one, this one, this one, this one. The idea is that you can then have sequenced events. This happens, and this happens, and this happens, and this happens, based on circuits being opened or closed. Now, looking at this, back here on this side of it, which is also being driven by it, is what we call a swiper board. And you see these two here, swipers, they just turn and drag across these. Well, these, if you see the red wires and the blue wires and the black wires, see all these? These are the two wires that feeds over there. They're one on each side. That way, it only has to turn 180 degrees. It doesn't have to go all the way around 360. So it turns 180, lights every other light all the way around, or one light on each side, one on the left, one on the right, and then it just rotates all the way around. So there's a couple of things that are going on here. One, this is dirty. This is really, it's not bad dirty, but it's dirty enough that it could cause a problem. So we need to clean these on both sides, and these swipers, we need to clean the swipers. Now, this is one side of the circuit. So what feeds that side of the circuit? Well, this does. See right here? So while I was saying that it may have been the ground wire that is not working up there, because that was the only thing that was really common to all the lights. Looking at this, we've determined that's not true, because this wire right here comes in here, runs through this circuit, touches this swiper. This swiper then goes around through here to these that actually touches this. So if this swiper isn't working, then none of the lights are going to work because it can't get past this. Or if there's a broke connection between here and here, oops, sorry, hey, couldn't see that, could you? I'm looking at it. But if there's a broke connection between this piece of the swiper around this little circuit wire to these, then that could also be what's wrong. But more likely, see, the wire comes around this way, comes into here, it's connected to here, into here, and into here. Well, if this switch is dirty, then it's not going to work. Additionally, that wire, that gets fed by one of these wires. If this wire isn't getting the power that it needs from wherever it goes, and I don't know where yet, then it could also do that. So what we're going to do here is we're going to do a couple of things. I'm going to clean this up, the swipers up, and I'm going to check continuity between this point and this point, or here and here, and make sure that we've got good continuity there. We get these cleaned up. Secondly, we're going to clean each and every one of these switches on all of these. Here, there's switches back here on the back that we're going to clean. There's a switch or a mechanism down here. We see this mechanism working, but what's interesting about it is that one of these there's two micro switches down here. I don't know if you can hear it, but I'm trying to see if they're clicking. That one does. This one may not. But anyway, we need to check and see if these switches, and it may not be clicking because it's already on. Well, no, it should be off. So here's the thing about switches, the thing to understand. Switches have only two, they're either closed or they're open. Closed or open, and that's it. Also, switches have two positions. They're either active or inactive, or at rest. They either call what I call activated or at rest. So for example, let me find a switch that we can see easier. All right, we'll just use one of these. So this switch right here, right now, if we look at the mechanical process, the wheel up there pushes this. You see how it moves those two switches downwards? Click and off. Click and off. Okay? This, when it's up like this, see there's a bump right here where my finger is. That's what's activating this as it goes by. Actually, it's on, nope, I was wrong. It's on this one here. So there's a hole in there. So right now, with the holes not there, it's in the position what I call at rest position. When it gets activated and it's pushed down, that's activated. Okay, so you have an at rest position, and you have push down, you have an activated position. At rest, activated. Now, so in this case, these two switches, when it's at rest, the position it's in now, the switches are open. When that gets pushed down, it's activated, the switches are closed. Now, so activated, it's open. At rest, it's open. Activated, it's closed. But the switches may not be that way. It may be that the switches are in the at rest position, they're closed, and when they're activated, they're open. So you need to make sure that the mechanical aspect of it is working, activated and inactivated, and it's moving the switch the right amount of distance to open and close that switch based on whether it's closed or open during each one of those modes, active or inactive. So we're going to clean all the switches. We're going to make sure that their activations are working like they're supposed to. We're going to oil these chains. Now this is really interesting because of the fact, like I said, in most pinball machines, the pinball drive motor, score motor that we call it here, drives this just cams. But because this drive motor, I guess, has to drive such a large swiper back here in the back, they use this chain mechanism, which I really don't understand. I don't see that much of a difference between, if there is any difference between the cog size on this side as the cog size on this side. So they look to be the same size, so it's almost as if they're turning the same speed. And if they're turning the same speed, why not just put the thing up here and drive it? Whatever, I'm not the engineer that figured it out, but that's what they did to this. It may be that these are off just a little bit, because remember, a lot of times they were using whatever motor they had active, and it may be that this motor that they had was the closest one they could get, yet it didn't drive it at the right speed. In other words, get all this done while we made the 180-degree turn that it needs to make in here. So they use this chain in a different size cogs in order to get the right turn distance on a single turn of the motor here. So anyway, we're going to oil this up. We're going to clean this. I am seeing this motor turn, so I know the motor turns. It's not like the other one was where it was froze up. The timer motor was froze up. This one is moving okay, but it's very dry. We're going to oil these up here a little bit. This would be the only places that I suggest that you put oil on electromechanical machine, is on devices like this that really, and just on this thing. Oil is a terrible thing to put in the end. You see all the dust, right? Add oil to the dust, what do you get? Gunk that ties things up. So, you know, unless it specifically states oil here, don't oil here. Okay, all right, so we can clean this up. We'll see what happens, see if we got our lights. All right, we got it cleaned off. I'm going to turn off the, well, crap. Okay, so I've turned off the thing so you can turn off the light so you can see. I've got it cleaned up now, but watch this. There it goes. Now, it appears that only one side works at a time, and it's every other side. I do have a section that's not lighting in here, and we'll have to figure that out. The game is over. The timer ran out. I've got a buzz in my amp now, probably because I left it on all night last night, so something made it buzz. So I suspect I've got a transistor gone bad in the thing. So, but anyway, the lights are working 90%. I think there's a issue. I have to figure out which side it is, but there may be an issue in the way the swipers are touching on one side. But anyway, the lights are now working. It's all in this unit. Cleaned up the unit, cleaned up the switches, and gonna screw this back. Normally what I would have done is I would have just pulled this mechanism out, set it on the floor to where I could work with it. Unfortunately, it's tied into the main wire loom here and on the other side, going back down in there. Anyway, I couldn't pull it out. So, and I really don't want to take this swiper mechanism off, simply because, geez, trying to put it all back together might be a bigger challenge than taking it off is. So anyway, it's kind of hard to see because of the lighting, but anyway, we got to see the lights work. Yay! Okay, one other thing. I've got it all buttoned back up now. Put the screws back. It's all held together. You can see that's all nice and shiny now. I cleaned that up with WD-40, okay? And it might need a little bit more cleaning over there on that side, but I cleaned it all up with WD-40, and that's it. And the reason I say that's it is because this stuff has a coating on it, or it's made out of copper, right? The thin layer of copper or conductive material, right? And if you get that off, well, you've just kind of really done it in, right? And matter of fact, even on the little motor board here, there's this little paper that says, do not use sandpaper or file on the surface of the printed circuit. They call it the rocket cam. Now, this was covered up in dust a while ago. We couldn't see it, but now we can, now that I've wiped the dust off of it. But, so, the thing that I want to make sure that everybody understands is that you can clean these, but you need to be really careful, Using WD-40 usually does a really good job. Some deoxit will do it, but deoxit is really expensive for what we're using here. So, you know, yeah, use that. Oh, and the other thing that I didn't use a while ago, and I probably should have, there's a neat little switch right here on this one. You can't really see it, but it says service light switch. You turn this on, woohoo, look at that. We got full light now. Okay, anyway, well, we can see it. And I've been sitting here working in the dark. Okay, well, there you go. Okay, one other problem they were having is this unit here, we weren't seeing score lights light up. Every time you hit something, it should move a score light. This is called a stepper unit, and this is a reset stepper unit. And what I mean by that is is for scoring. So when you hit a target, it clicks once and it moves it once. See it moves? See that reel move once? Moves again, moves again. That's stepping up. So there's a stepper unit. But I call it a reset stepper unit because whenever the game restarts, it wants to reset the score all the way back. Well, when it reset happens, this goes down and it resets all the way back to 0, and you'll see the wheel spin back. Zip. See it go back now. So it steps up and resets all the way. On the back here, this is where we're seeing, you see all the little dots? That was dirty. There's also a swiper, and you can barely see it here, that goes underneath this piece here. So this circuit along here comes around this little piece, connects into here, and that's where the arms get their power. So all that had to be cleaned, pulled apart, cleaned. But this one's easier since it's not as complex as the other one. This little screw right here in the center, I was just able to unscrew that, pull it off, clean all the piece, and then put that back. Now, these stepper units, sometimes you got to be really careful because while this one doesn't have one, a lot of times there's a spring in here, and when you undo this, it pops that out, and then you're reset, and all this is kind of goofied up. So what I did was just replace that. Now there's another thing that I noticed. It's not that bad. I mean, this is resets not used, but there's some play in here. There's a little plastic sleeve in here. That sleeve right here where my finger is bad. You can kind of see where the gap is, and that wiggles a little bit, but it's not that big of a deal. It seems to be working okay, so we're going to leave it like it is for now. Normally, sometimes what I do is we'll pull that off, pull this screw off, pull the swiper off, undo this screw, and there's one on the other side, this one here and this one here. This board comes off. This whole mechanism comes out. I can take it out, completely clean it up, get all that nice and clean, put all these back together again. But generally I do that when they're not functioning right. This one seems to be functioning okay, and sometimes it's better just to, don't fix what ain't broke. So going to clean up this switch down here. This is a 0 position switch. When it's at 0, you see how it's opened up. But when I add a score, which I'm fixing to do, when I add a score, you see how it moves? Okay, but see, this is what I was talking about, how at rest and not. So at rest, if this was to be connected, I can't really see. Yeah, see, it barely touches right there. So at the rest position, when it's in the reset position, which I just did, that switch is now open. But once I move the first score, this should now be connected, and they're barely connected, but I'm going to clean that up, make sure those are right. But that is just really jankied up. You see how all bent that is right through there? It really needs to be more straight to make sure that it's operating function. So we're going to clean that up, make sure that's right, and then the actual score light mechanism should be working fine then. All right, so looking at the way the roller works, this is interesting. So the roller, the big long canvas, remember that the canvas was on there and it goes all the way up and over and back down and back up and back down again. But the main scene where you're seeing the roller, which is really interesting, it just fell over, is here, rolls across here, across this bottom piece, over these lights, and up this side. Oh, okay, I gotta stand up, obviously. Okay, so looking at this is what's really interesting about this, is that there's a roller down there on the bottom. So the canvas, let's just start there, rolls over this, goes over the top of these lights. These lights are where the 5 different areas of targets are, because if you hit the target, those lights flash, shine through the thing, and make this red color flashing, boom, 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 makes the explosion. So that's where the target is when you hit it. However, this is what's interesting, is the carpet comes up, goes over the top of this one, or over this edge at an angle, over the top up here, which is the one that's driven by the motor and that belt, over this one, down the back, all the way down, loops around that one, and you can see this one has a chain on it, has a spring on it, so this one springs up, loops underneath this one, comes up on the inside now to here, to about here, up here at the top, and then it turns around and loops down and comes back, and it's going this direction over each of those feelers now, and then it turns around and starts to track back of it. So basically, the explosion, in order for the target, has to be in the right spot here. This is where you're shooting it, right? That's where the explosions are happening. But the sensors that are here, that are riding on the back of the canvas, are that far away from where it is. So the sensors ride here on the carpet, goes down, comes up, and goes around. So how do the sensors work? Well, I'll show you the thing on the back of the canvas, but if you can see it, there's these little feelers here, and there's got a little more wear here on the edge. So these feelers sit like this, and they run along the carpet, just like that. So they're just running along the carpet. There is no switch up here. These are simply picking up metal, just rubbing along the back of the car. And if you notice, this one is connected to this one, which is connected to this one, which is connected to this one, which is connected to this one. So each one of the ones that are on the inside of the pair are all connected together, because that's ground. Target area 1, target area 2, target area 3, 4, and 5. So, to know something in target area 1 was hit, these two would need to touch something metallic. And sure enough, on the back of that carpet canvas, in the right place, that's that which goes down and around that thing, back up over here. Remember, the lights are over here, so it's over here. It's got to go all the way down, up and around. In the right place, there's a little square piece of and I'm going to show you, like screen, metal screen. See? Right here. There's a little metal screen. So inside here, this is metal. So as those feelers come down, they hit this, they make a connection across there, and then however far it is, one way or the other, that's where that target is. So I was trying to figure out how the targets worked, based on how those switches were and where they lined up. But you can't tell where they line up because the sensor for the target is here, but the canvas has got to go down around this and back up again to this point. So it is actually, if you were to measure from this point all the way around and back up to that point, that's how far they're off in order for it to know. So isn't that cool? All right, so those switches were pretty dirty. The switches, the tracer contacts were pretty dirty. So I went through and put some deoxit on them and little WD-40 on the swivel points and made it work. The other thing that I looked at was the actual rollers. They seemed kind of stiff, and I thought, okay, well, maybe the bearings were gummed up. Well, there are no bearings. This simply uses, on these, brass bushings running on a rod. There's no bushing, and this feels slightly oiled. We'll probably put a little bit of 3-in-1 oil on it, these rods here, a little bit, just to make it happy, I guess. And then this is the same way there. So you see where I pulled out. This is the one that drives the main wheel. But you can see it's just a metal rod riding on a bushing. So we'll put a little juice in there just to keep it happy. But anyway, so I tried cleaning up the carpet, and I'm afraid to go too far on it, to mess with it too much, because I'm afraid the paint's going to come off. Whether I use water, Windex, or whatever, I'm afraid the paint's going to come off, so I'm not going to mess with it too much. I did a couple of spots that were really dark brown where some of the dirt sat. I got that. I am going to take some deoxit, spray it on a paper towel, and then clean up all the connectors, the little screen mesh, so that those switches can make it. But other than that, I don't think I'm going to do much more than that. And then I've got to get the foam stuff that fits over this, that glues down to these, because there should be a foam mesh all the way around this, so that when the canvas runs over it, it's not the canvas on this metal, but actually on something that's cushiony and adds a little more friction to it. So, all right, next thing. Okay, obviously I don't have the canvas in there, but yeah, you can see, and I don't know if you'll be able to see it or not, but as I move the plane, move the controls, and they move across the thing, it actually, those lights are actually where now it says mission completed. The lights are actually where the rockets hit. So if you're moving left to right, it will actually sequence down multiple lights. So it's not necessarily hitting an explosion that's counting points as much as it's just showing where the rockets blow up. And if you happen to blow up in an area where there's something that you're supposed to be hitting, then you get the score that's supposed to go over here and light up on these scores. So anyway, too much light trying to get these things, but that's pretty cool. It's getting close. So what we're working on now is the individual rollers. These were the rollers that held the canvas across the top of the machine. Now, made several inquiries trying to figure out what we wanted to put on there. If you notice on this one, you can see, I've already cleaned this one up, but you can see in between those lines, see that right there? That's a spot where glue was. So it was glue, and the old backing, whatever it was they had on there, there was just, the other stuff just turned to powder, but there was all that stuff on there. So what I did was I took a wire brush, cleaned all that off. I've done 2 reels so far now, and there's another one. And you can see the various glue stains. This one, yeah, I'm not sure. The ones I've seen, of the other ones that they were just strips. And on my canvas, you can see where there's like a roll here and a strip here and a strip there and a strip here. It was like just different strips where that thing rolled on, and it made an impression in the actual canvas itself. Well, I'm going to try to avoid making that happen. So what I'm going to do is I'm going to cover the whole thing. And what I'm going to cover it with is this stuff. So this came in a big roll, 20 by 4 by 48 inch roll. I was able to split it down into two so that I then cut a section off. There, I'm trying to straighten it out there. I'm using Joe's gridiron fight as a work table. Anyway, so now the cork material is laid out. It's flimsy, and it can do. So this will now wrap around the around those rolls. And what I'm going to do is I'm going to use this Fast Tack upholstery adhesive. Again, I got the cork and this from the local hobby store. And so what we'll do is we'll spray this on there. We'll tack that on there. And this way the whole roll is covered with this one tack that I hope will help the canvas last longer, and also give it some cushion, because we don't want it to be on hard on that roll, but we want it to be cushiony. So that's what hopefully this will do here. So the next step is going to be spray some tacky on thatty, and then sticky to thatty, and hopefully that'll work. But before I do that though, since I know this one now fits all the way around and fits tight, I'm going to use this one as a pattern and make, as I cut that piece and that piece, we'll be cutting it down, and hopefully we'll make, let's see, I've got 2 rolls there, and then, oh wait, it's in here. And then 1, that's 2 over there, so 3, 4, 5, but this one's a lot smaller than the other one. So we've got 4 large rollers and 1 small roller. The small roller was just used to bend over the top before it caught into the where the main drive one is here at the top. So, and this chart here even shows you how to thread the canvas over the top of it. Yeah, that, and how to adjust it so it rolls right. Okay, all right. So next time, hopefully, we'll have all the canvas on there before we start putting all the cork on there before we start putting the canvas back on it.